Today we're going to be doing some electron configuration practice, and we're going to be doing the 3 different types of notations for electron configuration, and we're going to go ahead and start off with orbital notation, and our orbital notation is going to be for the element lithium. So in orbital notation, I not only have to account for each individual electron, but I also have to draw them, which means I need to find them on my periodic table first. So lithium is going to be right here. It's going to be Li, and it will be my 3rd electron. So I need to account for all of the electrons up until my very 3rd electron. That's the last electron I have to account for. So my 1st and 2nd electron are going to live in my 1s orbital. And the s block is going to look like this, just one box. And I did not reach my 3rd electron before I finished going through my first s orbital. So my s block is going to be completely full before I move on to my next electron, which happens to be my very last electron. Li is my 3rd electron, so I only have to account for one more electron. That 3rd electron is going to live in the 2s block. The s block still looks like one box. But since I only have one electron inside of that s block, I only have to draw one electron, and then I'm done with the orbital notation for lithium. Now the shorthand notation for cesium, I'm going to follow the same steps, but this time I don't actually have to draw out my different orbitals. Instead, I can just tell you how many are going to be inside of that orbital. So I have to find cesium. So cesium is going to be all the way down here. It's going to be my 55th electron that I have to maintain. So it's a good thing that I am doing shorthand notation, otherwise my hand would start to cramp. And so I'm going to follow the same procedure. So my 1st and my 2nd electron are going to be in that 1s block. And I have both of those electrons accounted for because I'm getting all the way to 55. So I will have 2 electrons inside of that 1s block. Now my 3rd and 4th electrons are living in that 2s block. And that s block is going to be completely full because I have not reached the 55th electron yet. And so I will continue to drag my finger across the periodic table. I've now reached the p block. This is going to be 2p, and I have not reached element 55 by the end of 2p, which means that my p block is going to be full, so I can say 2p6 and continue on. My 11th and 12th electrons are going to live in my s block, and that's going to be my 3s block. My s block is going to be full, so I will say 3s2. Continuing to drag my finger across, my 13th through my 18th electron are going to live in my 3p block. And I have not reached my final electron, so that means that my p block is going to be full at 6. And I will continue to my 4s block. My 19th and my 20th electron live here. And my s block is going to be full, so that's going to be 4s2. My 21st through my 30th electron are going to be living in my D block. And remember that this D block is not going to follow the nice little numerical thing over here that my P block, my S block do. The D block is a less desirable zone for the electrons, so the energy level is lower. So this first D block is actually going to be 3D. And my 55th electron is going to be after that 30th electron, which means that my D block is going to be full, so I can go ahead and say 3D10. Now, my 31st and my 36th electron are going to be back in my P block, and that is going to be 4P. And I have not reached that electron yet, so that P block is also going to be full. Then I'm at 5s here. My 5s orbital is going to be full, so I can go ahead and say 5s2. Continue on. I'm in the D block now. Remember that it does not match the row number. It's going to be one less. So this is actually going to be my 4D. And it is going to be completely full. So I will say 4d10. I'm running out of room. And then I'm going to be my P block here. So this is my 5th P block, so 5P. My P block is going to be completely full here, so I am going to go ahead and say 5P6. And then finally, I've reached my last electron, that 55th electron, and that is going to be 6s. And since I only have that 55th electron and not the 56th, I'm only going to have 1 electron in that 6s orbital, which means I will only say that I have 6s1. Again, very happy that that was not an orbital notation that I had to do there. Otherwise, that would have been a nightmare. Okay, so now I have noble gas notation for fluorine. My noble gas notation is going to be my shortest notation. So all I need to do for my noble gas notation for fluorine is I need to find fluorine, and then I need to find the noble gas that has less electrons than fluorine. My closest neighbor with less electrons. So if I backtrack, I will see that my helium atom is going to be the nearest noble gas. So I will say bracket helium bracket. And that takes the place of my first and my second electron. Not a huge time saver, but when we're in larger atoms, it is a huge time saver. So I don't have to account for my first and my second electron. I just have to account for electrons 3 to 9. So my third and fourth electron are going to live in 2s. And my 2s orbital is going to be full, so I will say 2s2. And then my 5th through my 9th electron are going to live in 2p. I do have to be careful here. My P block is not full. I only have 1, 2, 3, 4, 5 electrons inside of my P block. So this is going to be 2p5. Next, I'm going to have orbital notation for nickel. So nickel is going to be right here. It is going to be element number 28. So I need to go ahead, stretch out my hand, and get ready for a longer one, as my orbital notation is where I have to actually draw those electrons. So I'm going to start with my first and my second electron. My first and my second electron are going to live in that 1s block. Okay, and that 1s block just looks like one box. I do have both of my electrons living there because I have not reached my 28th electron by the time I finished 1s, so I will go ahead and draw it as full. My third and fourth electrons are going to live in 2s. And again, I have not reached my 28th electron, so I'm going to draw it as full. My 5th through my 10th electrons are going to live in 2p. My P block has 3 total boxes here. And as I fill my P block, I need to be careful to be following Hund's rule. And so I'm going to draw my electrons alone as long as possible before I actually go back in and force them to double up. Now after my 2p, I am at 3s, and that 3s block is going to be full because I have not reached my 28th electron here. My 13th through my 18th electron are going to be in that 3p block. P again is going to have 3 boxes here. And I am going to, as long as possible, try to keep my electrons alone until I have to go back in and force them to be together. So that's my 3p block. That will take care of electrons to 18. Now all I need is my 19th and 20th electron, which is going to be in my 4s block. S again is just one box, and my 19th and 20th electron are going to occupy that fully. And now I am where I need to be careful and watch out. I am in the actual orbital that my element desired is going to be in. That is nickel. And so I need to be super careful. I am in 3D here. And my d orbital is going to have a total of 5 boxes. And I again need to be super careful to make sure I'm following poly, Huns, and off-bow when I'm filling these boxes here. So I only have 1, 2, 3, 4, 5, 6, 7, 8 electrons to fill, which means some of my electrons are going to be alone, and I'm going to do my best to make sure that those are the correct ones. So I only am going to draw 8 arrows, and I'm going to try to draw them alone. So 1, 2, 3, 4, 5. Now I've run out of rooms for those electrons, and now they have to double up. So my 6th, 7th, and 8th electrons are going to be here. And you'll see 2 electrons get to be alone. Lucky them. Okay, so that is my orbital notation for nickel. Next, I'm going to do shorthand notation for krypton. Krypton is going to be element number 36 here. I'm going to go ahead and start, again, shorthand notation. Don't actually have to draw out the orbitals, but I do have to tell you how many electrons are going to be in each. So my first and second electron are going to live in 1s. And I did not reach the end of my 36 electrons by the time I finished the 1s orbital, so my 1s orbital will be full, so I will say 1s2. Then I have 2s, have not reached element number 36 yet, so my 2s orbital is going to be full, so I will say 2s2. Then I'm in my 2p block. I have 1, 2, 3, 4, 5, 6 electrons here, have not reached my final one, so I'm going to go ahead and say that that is going to be full, so 2p6. My 11th and 12th electrons are going to live in that 3s block. Again, have not reached my desired electron, so that means I'm going to go ahead and say that my 3s block is full. Continuing on, my 13th through my 18th electrons are going to live in the 3p block. I'm going to have a full 3p block, which means that I will have 3p6. And I will continue with my 19th and 20th electrons, which are going to live in that 4s block. My 4s block is going to be full. I have not reached my element yet, so all my orbitals will be full until I reach it, and that's when I need to be careful. My 3d block is also going to be completely full. Krypton does not live in the d block, so this is my last block that will be, by default, completely full. So I will go ahead and write that 3d is going to be completely full at 10. And now that I have reached the actual orbital here where krypton is actually going to fill to, I need to be careful to make sure I know exactly how many electrons are going to be there. So this is my 4p block. And my 4p block, I need to count how many electrons I'm going to have until I get to krypton. So I have 1, 2, 3, 4, 5, 6. So my 4p block is actually going to be completely full, which makes sense because krypton is going to be a noble gas, which means that they have 8 valence electrons. These numbers in front denote the energy level. The highest energy level are going to be my valence electrons, so that would be 4s2 and 4p6. These two together, 2 and 6, when I sum those up, that is going to equal 8, which is the number of valence electrons for my noble gas. So this makes sense. Next, I'm going to do the noble gas notation for silver. So I need to go ahead and I need to find silver. Silver is right here. It is Ag. It is element number 47. So I am going to find the noble gas that is closest to silver, and that happens to be the one that we just did the electron configuration for, which is going to be krypton. So all I need to do is say bracket krypton bracket, and that will save me writing out all of this again. And now I just need to account for the electrons that krypton does not have, which is going to be electrons 37 to 47. So my 37th and 38th electron are going to live in that 5s block. And my 5s block is going to be full, so I'll say 5s2. And then I'm in the block that silver is actually in. So now I need to be careful to make sure that I am labeling this with the correct number of electrons, as it is not default full. So right now I am currently in the 4D block. And silver is going to be my 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth electron inside of my 4D block. So I will go ahead and say that this is 4D9. Next, I have orbital notation for arsenic. Arsenic is going to be element number 33 here, and so we're going to go ahead and start off. We do again need to draw every electron that is here, because that is what orbital notation is here for, so that we can see if we're following Aufbau-Hund's and the Pauli exclusion principle. So we need to actually draw those out. My first and second electron are going to live in my 1s block. The s block looks like 1 square. I did not reach electron number 33 by the time that I finished the 1s block, so I will draw the s block as full. My third and fourth electrons live in 2s. The s block again, 1 box. I will draw 1 up and 1 down, as my s block is full. My 5th through my 10th electron are going to live in 2p. My p block looks like 3 boxes, and I am going to draw it as full, but again, I am going to make sure that I am following my rules, and I'm going to try to let those electrons be alone for as long as possible before I force them to be together. So that's my 2p. So now I need to account for my 11th and my 12th electron, which are going to live in my 3s block. S block again, 1 box, 1 up, 1 down, because I am full. Then for my 13th through my 18th electron, that is going to be in my 3p block. P again has 3 boxes here, and I'm going to fill up the 3p because I have not reached my 33rd electron yet. But I am, again, going to try to let them live alone for as long as possible before going in and adding that neighbor. But my 3p block is full. After that, my 19th and my 20th electron are going to live in my 4s block. The s block again, 1 box. I'm going to have 1 up, 1 down, because my s block has to be full. And then I can account for my 21st to my 30th electron. My 21st to my 30th electron are going to live in my 3D block, and it is going to be completely full because arsenic is not in here, so I can go ahead and say this is default full. That will be my 3D block. My D block again has 5 boxes inside of it, and I'm going to do my best to leave them alone for as long as possible, but I do need to completely fill this. So first, second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th electrons will fill like this. Finally, I am in the orbital that arsenic is actually in. I'm finally in 4p, so I will go ahead and draw that 4p orbital. That p block again is going to have 3 total boxes, but here I need to be careful to make sure that I only draw the electrons that arsenic actually has, and arsenic inside of that 4p block is only going to have 1, 2, 3 electrons. So lucky electrons, they get to live alone inside of those orbitals. Next, I'm going to do shorthand notation for silicon. So I need to find silicon first. Silicon is going to be Si, it's going to be element number 14, and shorthand notation means that I just get to tell you how many electrons are actually going to be there. I don't have to draw them out. So my first and second electron are going to live in 1s, and my s block is going to be completely full, so I will say 1s2. My third and fourth electron are going to live inside of 2s. My s block is going to be completely full, so I will say 2s2. or electrons number 5 to 10 are going to be in that 2p block, and it's going to be completely full, so I can go ahead and say 2p6. Electrons 11 and 12 are going to live inside of 3s, and it will be completely full, so I will say 3s2. And then finally, I'm going to reach silicon on my actual periodic table, which is going to be my 14th electron. My 13th and 14th electron live inside of 3p. But I need to be careful here. My p block is not necessarily filled. I need to count how many electrons I'm actually going to have. So for silicon, I'm going to have just 2 electrons inside of that 3p block. And that will be my shorthand notation for silicon. Finally, I just have the noble gas notation for iron. Iron is going to be element number 26. And since I'm doing a noble gas notation, I need to find its closest noble gas. So I need to backtrack. So whenever I backtrack, I see that my closest noble gas is going to be argon. So I will go ahead and say bracket argon, bracket. And then I just need to account for the electrons that argon does not have, as just saying argon's name accounts for electrons number 1 to 18. So now all I need to do is account for electrons 19 to 26. So my 19th and 20th electrons are going to live inside my 4s block, and my 4s block is going to be completely filled. And then my 21st to my 26th electron are going to live inside that 3d block. And I just need to make sure how many electrons are actually going to be there. So inside of my 3d block, I need to count up until iron, and that would get me to 1, 2, 3, 4, 5, 6 electrons. So iron only has 6 electrons inside of its final orbital here, and that's going to give me 3d6.